class. Today we're going to do an FMEA example. Now, as you recall, the kind of safety that we do in modern times is really proactive. What we're trying to do is to anticipate risk rather than react to it. For example, if you see a plug in the wall that has been broken, it's sort of too late to anticipate that risk might occur because it's already happened. So we have some sophisticated tools to anticipate risk. All right, one of the first tools that we're going to study is a failure modes and effects analysis, FMEA. It stands for, again, failure modes. In other words, the number of ways that something can fail, and effects analysis. In other words, we're going to look at the way something then can fail and the effects of that failure. Now, an FMEA is an inductive form of analysis, and that means it looks at each component of a system and follows that component to see how it could affect failure of the whole system. And if you recall, inductive versus deductive, deductive means that we look at failure first and then look at what might cause it. An example of a deductive system is a fault tree, which we will have later. But today we're going to look at an inductive system. And you will see the FMEA form about an aircraft braking system. And I'm going to show you an example of how to fill it out. Okay, class, let's take an example. We're going to look at the components of this particular system and see how they might fail. See the methods of failure and the effects on those failure on the entire system. So let's look at component number 1, which is the brake pad. Okay, the brake pad can fail in 2 ways. The glue can separate on the pad and the tread can wear thin. So our first way is the glue can separate on the pad. All right, that's the first way that the brake pad could fail, is the glue could separate. And the second way is that the tread could wear thin. All right, so these are the 2 primary ways that the brake pad could fail. The effects on other components. So right here, the glue failure can corrode the metal beneath the pads. So the glue failure can corrode the metal. See, this is the way that that particular failure can affect some other components. And let's look at how the tread wear can affect the ergonomic space between the foot and the top of the brake box. So what we have with the failure of the tread wearing thin, that can affect the ergonomic space. All right, so what we've done is we have looked at the different ways the brake pad can fail. That's the first component we looked at. And then the effects on other components. These next 3 boxes, severity, probability, and RAC, are things that we're going to look at a little bit later. Let's look at detection methods, all right? So how could we detect this? let's look at our example, and it shows that a warning light comes on if metal pads become damaged. All right, that's one warning method. If the metal pads become damaged, there's a warning light. All right, we do have one way that we can be warned. Now, redundancy means that do we have another thing to do if this happens? And we don't have a redundancy, so we have none here. We have no backup. If this happens, we just have a warning light saying that it's going to happen. And obviously, you can see that might be a little bit of a problem. And our second mode of failure, which is the tread can wear thin. All right, what other information do we have there? Well, we see that the pilot may notice if the dimensions of the box change. So he may notice something. So really the only detection method that we have here is that the pilot may notice. That doesn't seem too good to me because it's too late then, isn't it? All right, and again, we don't have any redundancies. We don't have a backup when that particular thing happens. So we have filled out the first component on the brake pad. Let's look at the second component, and we kind of fill that out in the same way. All right, class, as you can see, I filled out the second component, which is the hydraulics. I filled that out in exactly the same way. I read the paragraph and filled in all the information that I have on that paragraph. And here are the results. As you can see, we still don't have very many detection methods or redundancies, do we? So we don't have much backup in this system. All right, so what we're going to do now is fill out the middle portion. And so I'm going to go back to the first component, and let's see what information we have on severity, probability. As you remember, when we did our risk matrix, remember the nice colors and severity and probability and how we rated those? We're going to do the exact same thing here. It's actually fun. We can look on a colored chart and decide what we need. It's actually very easy to do. So let's look at any kind of data that we have on severity here for the first one. So in other words, what we're going to do is we're trying to figure out how important this particular failure is. All right, the brake pad failure. Okay, so the brake pad itself is what we're looking at. We're not looking at necessarily the severity of each component. We're looking at the severity of the brake pad failure itself. So let's see what information we have about that. The brake pad failure may occur once in 5 years, and this could result in losses exceeding $200,000. So we have probability and severity here. So what we're going to do is we're going to go to our third page, which will show you what this means, and we'll go back to our risk matrix. And we're going to use the same kind of designation that we used in our exercise about Marquette, Minnesota. So let's go back, use this information, and fill in with our 3 boxes. We'll use our matrix to fill in the values there. All right, let's look at the 2 risk values and see if we can't figure out what they are. Here's our you can see on the screen is our risk matrix, and then the description of the particular values that we assign to each of the situations. All right, so for component 1, the brake pad failure may occur once in 5 years. Let's go over to probability and see if we see things once in 5 years. So that would be E. All right, so we're going to only experience this once in 5 years. So let's keep that in mind. That's E. That's in our probability. All right, how about our severity? This could result in losses exceeding $200,000. So let's see. Looks like we've got it right here. Could result in losses exceeding $200,000. That is 2. So it looks like we've got 2E. And 2E, get these colors away so we won't be confused. We don't want to get confused, do we, class? Okay, so 2E, let's see, here's E. 2E looks to me like that is, again, in the yellow zone. Just kind of a coincidence. So 2E is kind of in our yellow zone. Let's look over here. Yellow is our area in which administration has to make a decision about whether or not they want to fix it. Now, that means that it's not utterly critical. It just means that our administration needs to think about whether or not they're going to fix it. So let's keep in mind 2E. So our severity will be 2. And our probability will be E. Okay, so our RAC, which is risk assessment category, and that really means what color, is just what I explained. That's in the yellow color, and that means that management has to make a decision about whether or not to fix it. All right, class, let's look at component 2 and fill out the same information. First of all, we see that hydraulics failure may occur at least once per year. Let's find that on our chart. All right, likely to be experienced at least once per year. That sounds good. Let's make that blue just for fun there. Okay, likely to be experienced at least once per year. Okay, so it looks like our first value for probability is B. Now, this could result in losses exceeding $1 million. This is for component 2. Whoops, lots of money there. So, at exceeding $1 million would be category 1, wouldn't it? All right, so we've got 1B. Now, I just used blue to illustrate the point, but let's go down and find 1B on our matrix and see what color we're really in. Okay, B, 1 is catastrophic, isn't it? So here we are, 1B. Oops, we're in the catastrophic area. We're in the red, which means address this problem immediately, doesn't it? Okay, so we've got 1B. So let's go back to our form and fill out 1 and then B. Okay, and what we do at 1B, that's the red zone. So you know what the red zone always means. That means fix it right away. So address immediately. Here we've got our system all filled out. We've got our FMEA all documented. So we have the brake pad as one component, and it really is, you might want to call that system yellow, which means that we've kind of figured out that we don't have any backups, which are redundancies. That certainly is something we might want to do. But our risk assessment category is yellow. Let's just make it yellow for fun here. So, okay, that's yellow, which means management decision. That means that we really have to probably look into it a little bit more, look at our funds, and see if we find it to be a very important thing to do. Okay, our second component is hydraulics. And we've looked at our severity and probability data, and what we have decided is that we need to fix this thing immediately. So we've got our yellow and our red. So really, we have looked at both components and we've looked into the future to see how each might fail, and we've looked at the results of those failures. Now, which one of these would you fix first? I bet you could figure that out all by yourself. All right, so are you ready to do your own exercise? Go ahead and fill out your Dropbox assignment on FMEA and listen to this again if you have any questions.